Exercise 9G, compound interest investments with regular additions to the principal, and annuity investment. So the scenario here is that I've got an investment and I'm putting it in, and what I'm actually doing this time is I'm now making some further payments to increase the amount of the annuity. These are probably the hardest questions to do in the exam or SACs or things like that, because a lot of the questions, it's just really hard to get your head around. So it's worthwhile just understanding or to look at the wording and trying to work out. Often they're in the form of, we've got this situation, which one's the better deal? But we'll make our way through it. The things to remember here is that because it's an annuity, I'm investing the money, so the PV is going to be negative and the future value will be positive. So the FV value will be positive. So we have an investment amount, the original, the V0 is equal to the principal. We've got the recurrence relation, which is capital R times Vn plus D. This time that D is regular investment payments that I'm putting in. So it's not ones I'm taking away, I'm putting in money into it. So, but all the other things are still the same. 1 plus little r of 100. Little r is the interest rate divided by the compounding, or the number of compounds per year. Example 90.1. Ting invests $50,000 at 5.5% per annum, compounding monthly. She makes regular deposits of $500 per month. What is the value of the investment after 5 years? So again, we can set up the compound interest or the financial solver. So first things to notice that it is compounding monthly. So that means payments and compounds are going to be equal to 12. The N here is 5 years, but of course it's compounding monthly, so it's going to be 5 times 12, which will be equal to 60. We are getting regular deposits of $500, so that means that now that Ting is paying into that, so that's going to be a negative. So the payment is going to be negative 500. And we've got all the usual refinements. We've got that is 1%, or the I percent there, sorry, of 5.5. And then we've got the original amount there, that's the V0, so, or the PV. Let's may as well use the terminology. So we've got 60. We have 5.5. The principal, now she invests it, so that's going to be negative 50,000. The payment here, she's put in 500. We don't know what the future value is, but it's going to be a 12 and a 12. The future value is bang. There's our amount there, which is $100,225 and 60 cents. Do we need to round it to anything? No, we can just do it as it says. So therefore, after 5 years, it's going to be $100,225.60 after 5 years. Example 9E.2 comes from a VCAA exam, and I've chosen this one because most of the state found this far too difficult to even attempt, let alone get their full answers. That's because there's a lot of writing and a lot of procedure to do. Alex sold his mechanics business for $360,000 and invested this amount in a perpetuity. The perpetuity earns interest at a rate of 5.2% per annum. Interest is calculated and paid monthly. What monthly payment will Alex receive from this investment? The main thing to remember here is that it's a perpetuity. So the perpetuity means that if you remember that if I put the investment, the monthly payments are simply going to be the interest rate. Now I can put this into the solver, or alternatively I could work it out by hand because I remember the annuity interest. So that's going to be little r over, in this case it is 12, so it's going to be monthly, and it's going to be divided by 100 times by that 360,000, and then that is going to be equal to, so the little r is 5.2% divided by 12, divided by 100, and then times it by $360,000, and that gets me $1,560. Now, I could have got the same result from the financial solver. I just needed to put in 12, 5.2. We've invested in $360,000. We're working out the payment. The future value is still $360,000, and it will come up with the same amount, which is $1,560. B. Later, Alex converts the perpetuity to an investment, annuity investment. This annuity investment earns interest at the rate of 3.8% per annum, compounding monthly. For the first 4 years, Alex makes a further payment each month of $500 to his investment. This monthly payment is made immediately after the interest is added. After 4 years of these regular monthly payments, Alex increases the monthly payment. This new monthly payment gives Alex a balance of $500,000 in his annuity after a further 2 years. What is the value of Alex's new monthly payment? Round your answer to the nearest cent. Oh, good heavens, trying to work out what's happening here. Well, this one, it's may as well get little bits of the story at a time. In the exam, I would again put in all my financial solver bits as I go. So what I'm going to do is I'm going to clear all this. I'm going to go back and let's just put little bits and pieces in. So let's put in things that I know. So we know that the interest rate there is 3.8. It's compounding monthly. So that's going to have a 12 and a 12. For the first 4 years, so the first 4 years, so we're going to do 4 times 12. Alex makes a further payment each month of $500,000 to his investment. So we're going to assume that his investment is still that $360,000. And he's putting in $500 each time. The monthly payment is made immediately after the interest is added. That's just meaning that we're just it's the compound interest. That's a sentence that says compound interest. So that's part one. So let's go and find out what the future value is. So that's how much he earns after those 4 years, which is, so he gets $444,872.9445. So just for part one's sake, just translating that, I'm actually just going to record that so that I don't lose this value piece of information. So then the next thing that I've got here, so this is this section, this first paragraph is now here. So the second paragraph says, after 4 years of these regular monthly payments, Alex increases the monthly payment. This new monthly payment gets Alex a balance of $500,000 in his annuity after a further 2 years. So it says there after a further 2 years. So we're going to do, and it's still monthly. So it's going to be 2 times 12. And how did I know it's still monthly? Because this is new monthly payment. So we're still doing monthly. It's still 3.8%. Now this time, instead of 360,000, what I'm going to do is I'm going to use the amount that he earns after the 4 years. So this is 444,872. Now I'm going to put a little minus sign there. And the future value after after 2 years is going to be that $500,000. So now, what is the value of Alex's new monthly payment? Just have to click on that. And now we've got here is $805.65. And that calculation there is this paragraph here. That second paragraph is this one here. What's the value of Alex's new monthly payment? We have discovered that there. And so therefore, round the answer to the nearest cent is $805.65.